everyone. In this video, I'd like to just add a little bit of structure to this idea of angles. We'd like to kind of standardize everything so that we can talk about certain angles, and I'll have a bit of the same visual going for now. So what I want to do next is talk about angles in standard position, which I see I didn't actually. Oh, let me choose a pen. Pen. Standard position. I didn't underline for you, but that's definitely something that we're going to want to know. So we have this idea, and you can see it up above. We have, oh man, I'm having trouble switching pens. There we go. I have this idea of an angle being this kind of free form. You draw a ray pointing in the old way, and then you rotate it, and you get an angle. And all I want to do now is take those angles and put them all so that they have the same initial side. And we're going to do that by putting them in the Cartesian coordinate system. So if we picture our Cartesian coordinate system, we have our usual x-axis and our y-axis. And what we do is we make, here, let me pick another color. We make the origin always the vertex. So that's kind of a nice easy point to always be referencing. And as we rotate from here, in fact here, let's use this same, we had this angle up above. Let's kind of imagine that same angle. So we have this rotation right here, and we're just going to move it down below and try and do roughly the same rotation. And this is still the angle theta, same angle, different position. So the initial side is always the positive x-axis. Initial side. And then the terminal side is wherever you leave that final ray pointing. And again, we can have positive and negative angles in here. And once we get into the Cartesian coordinate system, let's also start to play around with the idea of these angles being a little bigger. I drew all these kind of smaller angles, acute angles, less than 90 degrees. But they can certainly be bigger than that. So if you'd like to play around a little, follow the Desmos link. And we're just going to look, oh, wow, jumping around, look just like before, but our angle is going to be stuck into the XY plane. Okay, so here's my picture. I'm going to stretch this out just a little bit. And we have, again, our vertex is going to be the origin. And if you just pull this slider, you can see here, whoop. So we start with nothing. As we increase our angle, this is a positive angle. We rotate further and further around. And you can go past the y-axis. This is a bigger angle, but totally valid. You can go past the negative x-axis. You can keep going. You can go around more than once. This is just a bigger angle, and this one only goes around twice, but you could keep going around forever and ever and ever. And you can also go the opposite direction. So whoop, starting here, if we start with a negative angle, we're just going to rotate down from the x-axis. So now the up and down thing actually works a little better. If you're starting from the x-axis, rotating down, the positive x-axis, rotating down will give you a negative angle, and rotating up will give you a positive angle. So as we rotate in the opposite direction, again, we can keep going around. We can go around more than once. And you can do that forever and ever and ever. So you can travel around round in a circle infinitely many times. So this brings us kind of to an interesting point. Let me go back and pick an angle. Say right about there. There's more than one way to start at the positive x-axis and end up at that ray. So you're seeing one specific way right now. You're seeing that kind of smaller angle that just goes from the positive x-axis a little ways up to this terminal side. But notice, if I keep going, let's say that's the same. I don't know if it's perfect, but just imagine. You can get to the exact same terminal side with a different rotation. So those are not the same angle. This one's much bigger rotation, but it is the exact same terminal side. And you can also get there by going in the opposite direction, wherever I was, somewhere around there. So that's a negative angle. Again, not the same angle as either of the last two I showed you, but it does end up with the same terminal side. And there's a word for this. they are called coterminal. So let me move up a little here. Where is it? Right here. So if their terminal sides are exactly the same, I don't know why my mouse is holding out on those, you're getting what are called coterminal angles. I didn't leave myself very good room here. Oh, I think I see what I was thinking. Okay, I'm going to draw up above really quick first, and then I'll draw some in the XY plane. So, for example, I guess that's kind of the one we did there. Let's do, I don't know, like this. Okay, so if this is your initial and terminal side, and I'm going to repeat it a couple of times, not really worry about the XY plane, pretend that's the exact same angle, the exact same angle. So one rotation, or the exact same initial and terminal sides. One rotation that would make that, showed right there, is a small-ish positive angle. Another rotation that would get me to that exact same spot is a negative angle. Another one, you could go around more times positive, but let's go around more times negative. That rotation would get me to that same side. So there's infinitely many ways, because you can always just do another full lap around the circle and end up back where you started. There's infinitely many ways to get coterminal angles. So let's try just a couple more just to get the idea of this visual. So again, this is my initial side along the x-axis. Let's make my terminal side down here. And we'll start to assign numbers to angles, in which case you can actually give me the number. But again, just to get the visual, you could go a positive angle, you could do a negative angle, pick a different color, you could go around multiple times. And oops, I went too far. Oh man, it's going to erase the whole thing too. Okay, so let's see, which way did I go? Around and around and around. That angle, those are really ugly, but hopefully you kind of get the idea of, as long as they're ending up in the same spot, ending up with the same terminal side, they are called coterminal angles. Different angle, but coterminal, same terminal side. Okay, do you want to see one in the fourth quadrant? We'll just do it really quick. I think you're probably getting the idea. So initial side, and you don't have to draw that. I'm just really trying to emphasize it. Terminal side, let's say it's out this way. So here's a positive angle that ends there. Here's a negative angle that ends there. Here, what did we do last time with big negative? Here's a big positive angle that ends there. And those are all three unique angles, but they are coterminal. Okay, I think that's all I've got for this one. Thanks for watching.